Generally, 60 amps is the smallest service size typically allowed for a sign. This is due to the fact that signs often require high amounts of power for lighting and associated electrical equipment. The number of ground rods required will depend on local electrical codes and the soil conditions present at the specific site. In the majority of situations, 2 ground rods will be sufficient for a sign service panel. However, if the soil conductivity is determined to be poor, then additional ground rods may be required to ensure proper grounding. Installing a dedicated panel is advisable for a sign and its associated lighting. This provides isolation from other circuits and makes it easier to isolate the sign for maintenance or repairs. Lighted signs, message boards, and animated displays will require more power than non-illuminated signs. It is important to consider using energy-efficient light-emitting diode lighting to reduce operating costs. Overcurrent protection should be provided for all circuits within the sign panel. Regular inspections and maintenance are essential to ensure the safety and longevity of the sign system. The selection of the appropriate service size for a sign depends on several factors, including the type of sign, its power consumption, and local electrical codes. It is essential to accurately calculate the total load of the sign, including lighting, animation, and any other electrical components, to determine the minimum service amperage required. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads and determining the appropriate size of service conductors in overcurrent protection. It is important to consult the latest edition of the NEC and any applicable local amendments to ensure compliance with all requirements. Factors to consider when determining the service size include the following. Firstly, the type of sign. Illuminated signs, such as those with fluorescent lamps, light-emitting diodes, or neon lights, typically have higher power consumption than non-illuminated signs. Secondly, the size and complexity of the sign. Larger and more complex signs with multiple lighting circuits and animated features will require a larger service size. Thirdly, the operating hours. Signs that operate for extended periods each day will consume more energy and may require a larger service size to accommodate the continuous load. Fourthly, the ambient temperature. High ambient temperatures can affect the ampacity of conductors, so it may be necessary to increase the service size to compensate for dirting. Fifthly, the voltage drop. Excessive voltage drop can cause dimming of lights and malfunction of equipment, so it is important to ensure that the service conductors are sized adequately to minimize voltage drop. Grounding is an essential aspect of electrical safety, and it is crucial to properly ground the sign service panel to protect against electrical shock and equipment damage. The NEC requires that all electrical equipment be grounded in accordance with specified requirements. The grounding system typically consists of 1 or more ground rods driven into the earth, connected to the service panel and other electrical equipment. The purpose of the grounding system is to provide a low impedance path for fault currents to flow back to the source, which will cause the overcurrent protection device to trip and energize the circuit. The number of ground rods required depends on the soil resistivity at the site. Soil resistivity is a measure of how well the soil conducts electricity. Low soil resistivity indicates that the soil is a good conductor, while high soil resistivity indicates that the soil is a poor conductor. The NEC specifies that if the soil resistivity is greater than 25 ohms, 2 ground rods are required. The ground rods must be spaced at least 6 feet apart and driven to a depth of at least 8 feet. If the soil resistivity is less than 25 ohms, a single ground rod is permitted. However, it is generally recommended to install 2 ground rods for added safety and reliability. The ground rod should be made of copper or copper-clad steel and be at least 0.5 inches in diameter. They should be driven into the earth vertically and spaced at least 6 feet apart. The connection between the ground rods and the service panel should be made with a continuous length of copper wire or busbar. The size of the grounding conductor must be in accordance with the NEC. A dedicated panel for the sign and its associated lighting is highly recommended. A dedicated panel provides several benefits. Firstly, isolation. It isolates the sign circuits from other circuits in the building, which can prevent electrical interference and improve the reliability of the sign. Secondly, convenience. It makes it easier to isolate the sign for maintenance or repairs without having to shut down other circuits. Thirdly, safety. It provides a dedicated overcurrent protection device for the sign circuits, which can protect against electrical hazards. The dedicated panel should be sized appropriately for the load of the sign and its associated lighting. The panel should have enough circuit breakers to accommodate all of the sign circuits, with room for future expansion. The circuit breaker should be sized in accordance with the NEC and the manufacturer's instructions. Energy efficiency is an important consideration when designing and operating a sign. Energy-efficient lighting can significantly reduce operating costs and improve the overall sustainability of the sign. Light-emitting diode lighting is the most energy-efficient type of lighting available. Light-emitting diodes use up to 75% less energy than incandescent lamps and last much longer. Light-emitting diode lighting also produces less heat, which can reduce the load in the air conditioning system. When selecting light-emitting diode lighting for a sign, it is important to choose products that are rated for outdoor use and that are designed to withstand the elements. The light-emitting diode lighting should also be properly shielded to prevent glare and light pollution. Overcurrent protection is essential for protecting the sign circuits from damage due to overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current in the event of an overcurrent condition. The overcurrent protection devices should be sized in accordance with the NEC and the manufacturer's instructions. It is important to select overcurrent protection devices that are rated for the voltage and current of the sign circuits. The overcurrent protection devices should also be installed in a readily accessible location so that they can be easily reset or replaced. Regular inspections and maintenance are essential to ensure the safety and longevity of the sign system. Regular inspections can identify potential problems before they become serious, and maintenance can keep the sign operating efficiently and safely. The following are some of the items that should be included in a regular sign inspection. Firstly, visual inspection. Check for any signs of damage or deterioration such as cracks, rust, or loose connections. Secondly, electrical inspection. Check for any loose wires, frayed insulation, or signs of overheating. Thirdly, lighting inspection. Check to make sure that all of the lights are working properly and that the sign is evenly illuminated. Fourthly, structural inspection. Check for any signs of structural damage, such as cracks or corrosion. Fifthly, grounding inspection. Check to make sure that the grounding system is intact and that the ground rods are properly connected. Regular maintenance tasks should include firstly, clean the sign regularly to remove dirt, dust, and debris. Secondly, lubrication. Lubricate any moving parts to keep them operating smoothly. Thirdly, tighten any loose connections or fasteners. Fourthly, replacement. Replace any damaged or worn parts. Fifthly, painting. Paint the sign as needed to protect it from the elements. It is important to keep accurate records of all inspections and maintenance tasks. These records can be used to track the performance of the sign and to identify any potential problems. If any problems are identified during an inspection, they should be addressed promptly by a qualified electrician. Ignoring potential problems can lead to serious safety hazards and costly repairs. In conclusion, determining the appropriate service size and grounding requirements for a sign is essential for ensuring the safety and reliability of the sign system. It is important to consult the NEC and any applicable local codes to ensure compliance with all requirements. A dedicated panel for the sign and its associated lighting is highly recommended, and energy-efficient lighting should be considered to reduce operating costs. Regular inspections and maintenance are essential to ensure the safety and longevity of the sign system. The National Electrical Code, specifically Article 600, addresses the installation of signs and outline requirements for disconnecting means, branch circuits, and overcurrent protection. Furthermore, ensure compliance with local ordinances, which may impose additional restrictions or requirements for sign installations. Accurate load calculations are crucial for determining the appropriate service size. This involves summing up the power consumption of all components, including lighting, transformers, and control circuits, while considering any applicable demand factors outlined in the NEC. A properly sized service ensures that the sign operates reliably without overloading the electrical system. Grounding is a critical safety measure that protects against electrical shock and equipment damage. The NEC mandates that all exposed metal parts of the sign be grounded, including the enclosure, frame, and any accessible non-current carrying metal parts. The grounding electrode system should be installed in accordance with NEC requirements, which may include the use of ground rods, ground rings, or connections to the building's metal water pipe. For enhanced safety and convenience, a dedicated panel exclusively serving the sign and its associated lighting is highly recommended. This panel allows for easy isolation of the sign for maintenance or repairs without disrupting other electrical circuits. Additionally, it provides a centralized location for overcurrent protection devices, simplifying troubleshooting and ensuring reliable operation. Consider the long-term operating costs and environmental impact when selecting lighting for the sign. Light-emitting diode lighting offers superior energy efficiency, longer lifespan, and reduced maintenance requirements compared to traditional lighting technologies. While the initial cost may be higher, the long-term savings in energy consumption and replacement costs make light-emitting diodes a cost-effective choice. Overcurrent protection devices, such as circuit breakers or fuses, are essential for protecting the sign's electrical circuits from overloads and short circuits. These devices should be sized appropriately based on the ampacity of the conductors and the load requirements of the sign. Proper overcurrent protection prevents damage to the sign's components and minimizes the risk of electrical fires. Regular inspections and maintenance are crucial for ensuring the safe and reliable operation of the sign. Inspections should include a visual examination of the sign's components, electrical connections, and grounding system. Maintenance tasks may include cleaning, tightening connections, and replacing worn or damaged parts. Address any issues promptly to prevent further deterioration and potential hazards. Furthermore, documenting the entire sign system, including electrical schematics, load calculations, and maintenance records, is essential for future reference and troubleshooting. Accurate documentation facilitates efficient maintenance and ensures that any modifications or repairs are performed correctly. Consult with a qualified electrician or electrical engineer to ensure compliance with all applicable codes and regulations. These professionals possess the expertise to design and install a safe and reliable electrical system for the sign, taking into account all relevant factors and considerations. The installation of a sign typically involves several key components, including the electrical service, the sign structure, the lighting system, and the control system. The electrical service provides the power necessary to operate the sign, and it must be sized appropriately to handle the sign's load. The sign structure provides the physical support for the sign, and it must be designed to withstand wind and other environmental factors. The lighting system illuminates the sign, and it must be energy efficient and provide adequate visibility. The control system allows the sign to be operated and controlled, and it may include features such as dimming, color changing, and animation. When planning the installation of a sign, it is important to consider the local codes and regulations. These codes and regulations may specify the size and type of sign that is allowed, the location of the sign, and the electrical requirements for the sign. It is also important to obtain the necessary permits before installing the sign. The installation of a sign should be performed by a qualified electrician. A qualified electrician has the knowledge and experience to install the sign safely and in accordance with all applicable codes and regulations. Once the sign has been installed, it is important to maintain it properly. Regular maintenance will help to ensure that the sign operates safely and efficiently for many years. Maintenance tasks may include cleaning the sign, inspecting the electrical connections, and replacing any damaged or worn parts. The specific requirements for the electrical service for a sign will vary depending on the size and type of sign. However, in general, the electrical service must be sized to handle the sign's load. The load is the amount of power that the sign will draw. The load can be calculated by adding up the power consumption of all of the sign's components, including the lighting, the control system, and any other electrical devices. The electrical service must be large enough to handle the load, plus a safety margin. The safety margin is typically 25%. This means that the electrical service should be sized to handle 125% of the sign's load. The electrical service must also be properly grounded. Grounding is the process of connecting the electrical system to the earth. Grounding helps to protect people from electrical shock and also helps to protect the electrical system from damage. The grounding system for a sign typically consists of one or more ground rods that are driven into the earth. The ground rods are connected to the electrical service panel with a grounding wire. The grounding wire should be sized according to the National Electrical Code. In addition to the grounding system, the electrical service panel must also be protected by overcurrent protection devices. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. The overcurrent protection devices should be sized according to the National Electrical Code. The sign structure must be designed to withstand wind and other environmental factors. The structure should be made of durable materials, such as steel or aluminum. The structure should also be properly anchored to the ground. The anchoring system should be designed to withstand the wind load. The wind load is the force of the wind on the sign. The wind load can be calculated using the local wind speed and the size and shape of the sign. The lighting system should be energy efficient and provide adequate visibility. Light-emitting diode lighting is the most energy-efficient type of lighting available. Light-emitting diode lighting also has a long lifespan. The lighting system should be designed to provide adequate visibility. The visibility of the sign is the distance at which the sign can be seen. The visibility of the sign depends on the size of the sign, the brightness of the lighting, and the ambient light level. The control system allows the sign to be operated and controlled. The control system may include features such as dimming, color changing, and animation. The control system should be easy to use and understand. The control system should also be reliable and durable. The installation of a sign is a complex project that requires careful planning and execution. By following the steps outlined in this guide, you can ensure that your sign is installed safely and properly. Remember to consult with a qualified electrician or sign contractor to ensure that your sign meets all applicable codes and regulations. Also consider that the type of sign greatly influences the electrical requirements. Illuminated signs, especially those with older technologies like fluorescent lamps, have higher power demands compared to non-illuminated signs or those using modern light-emitting diode lighting. Animated signs with flashing lights or moving elements also require more power and complex control systems. The size of the sign directly impacts the power consumption, with larger signs needing more lighting and potentially more complex electrical components. The NEC provides specific guidelines for calculating the load based on the sign's dimensions and lighting type. The location of the sign can also affect the electrical requirements. Signs located in areas with high ambient temperatures may require conductors with higher temperature ratings to prevent overheating. Signs located in damp or wet locations require special enclosures and wiring methods to protect against moisture. Local codes and regulations often dictate specific requirements for sign installations, including permitting, wiring methods, and grounding. It is crucial to research and comply with these regulations to avoid fines or delays. When calculating the electrical load for a sign, consider all components that draw power, including lighting, transformers, control circuits, and any other auxiliary equipment. Use the nameplate ratings of these components to determine their power consumption and apply any applicable demand factors as specified in the NEC. Demand factors account for the fact that not all components will operate at their maximum power consumption simultaneously. Proper grounding is essential for electrical safety and helps prevent electrical shock and equipment damage. The NEC requires that all exposed metal parts of the sign be grounded using approved methods. This typically involves connecting the sign's metal enclosure to a grounding electrode system, such as ground rods or a building's grounding system. Select a qualified electrician who is experienced in sign installations to ensure that the work is performed safely and in compliance with all applicable codes and regulations. A licensed electrician will have the knowledge and skills to properly size the electrical service, install wiring, and connect all components of the sign system. Consider the energy efficiency of the lighting system when selecting components for the sign. Light-emitting diode lighting is a highly efficient option that can significantly reduce energy consumption and operating costs compared to traditional lighting technologies. Light-emitting diodes also have a longer lifespan, reducing the need for frequent replacements.